I'm here with Dr. Romano to do a video on equivalence point.
Hi, I'm Dr. Romano. I'm professor of organic chemistry here at Romano Scientific and the creator of the Orgoman products and the author of the DAT Destroyer book. I want to go over with you something called the equivalence point. This is a very hot DAT topic. When I say equivalence point, it's the point where the number of moles of acid is equivalent to the moles of base. I'm not sure why a lot of students think the equivalence point is always 7. It's not. It could be more than 7, less than 7, or 7, depending on the acid or the base that we're using. Now, what we're going to do is remember the concept. The stronger acid or base dictates the pH. Come around and let's have a look at what do I mean by the stronger component dictates the pH. Say, for instance, you titrated a strong acid and a strong base. HCl and NaOH would be two fine examples. Then the equivalence point, if they're both strong, would be 7. Easy enough. What if we had a strong acid and a weak base? HCl and NH3 would be a nice example. The stronger component dictates the pH, so it would be on the acidic side, so it's under 7. Don't go that much under 7. So the equivalence point in these type of titrations come in around 5-ish. That's easy enough. If you took a weak acid and a strong base now, again, HF would be a good example of a weak acid, and strong base could be NaOH. The strong component dictates the pH, so the equivalence point would be over 7. Again, not that much over 7, so it's up around the 9 zone. Easy enough. If they're both weak, it can vary. If they're both weak, it's close to 7. It could be a little over 7. It could be a little under 7. And that would be a much longer type of calculation. So I don't think for the DAT exam I would worry about if they're both weak. But if they're both weak, it would depend on which one is the more weaker. And like I said, it would be either above 7 or below 7, but pretty close. Let me work out a problem on the other board with you that I made that I think you're really going to enjoy. It says here that in an experiment we have 20 milliliters of 0.018 molar ammonia and was placed in a flask and titrated to the equivalence point using 0.120 molar HCl, and I give you the Kb of ammonia as 1.8 to the minus 5. And what I want to do is to find the volume of HCl needed to reach the equivalence point. I hope you remember this was done in what we call the titration. Now, what I like to use is this formula, normality. Now, the normality is always equal to or greater than. So it's equal to or greater than the molarity. If the acid has 1 H and the base has 1 OH, then that would be molarity equals to normality. So in a problem like this, where you have HCl and ammonia, this is considered monoprotic, and this guy is only going to be accepting 1 H. So the molarity and the normality is equivalent. I'll do another video where they're not equivalent. But 0.12 molar is 0.12 normal. So the volume of acid we don't know. The normality of the base is the same as the molarity here. So it's 0.18. And the volume of the base was 20. And that gave me 30 mLs. So this formula takes me to the equivalence point and gives me the volume of acid needed to hit the equivalence point, 30 mLs. Now, here's the tricky part. What is the pH after 15 mLs of HCl was added? Well, if it took 30 mLs to reach the equivalence point, 15 mLs is the half equivalence point. Now, at the half equivalence point, something very special awaits. The pH is equal to the pKa of the acid. If you got to bang that into your head, when you're at the half equivalence point, only half of the species has been neutralized. So that would mean that would put me at the 15 mLs. So all we got to do to get the pH is get the pKa of the acid. Now, you know the Ka times the Kb is equal to 1 to the minus 14th. We already know the Kb is 1.8 to the minus 5, so if you divide it out, you get 5.56 to the minus 10 is the Ka. The pKa is minus the log of this. Well, minus the log of this would put me quite under 10. It would put me around 9.3, 9.2 in that zone. Answer on the calculator came out to be 9.26. You can review logs with me on the study group, or you can look in the DAT Destroyer where I gave you some log practice, but that's important. So minus the log of this number puts me quite under 10, so 9.2. I hope this helps on giving you a good understanding of how to get the volumetric equivalence point and how to get the half equivalence point. I'll do another tape where I'll show you how to get a pH at an equivalence point in the next tape. All right, good luck to you and see you in study group. Bye-bye.